If x minus 2 is a factor of p of x, which is given here, find the value of k and write p of x as a product of linear factors. So if we know that x minus 2 is a factor, that means that we know that p of 2, remember 2 is the value that makes x minus 2 0, that's going to be equal to 0. So in other words, 2 cubed plus k times 2 squared, take away 3 times 2, add 6, that's going to be equal to 0. So that's 8 plus 4k, take away 6, add 6 is equal to 0. Now take away 6, add 6, those are going to cancel. So 8 plus 4k is equal to 0. Subtract 8 from both sides, 4k would be negative 8. Divide by 4 means k is negative 2. And so we know that p of x is x cubed minus 2x squared minus 3x plus 6. But also we know that x minus 2 is a factor. So it's got to be x minus 2, remember that's our linear factor, times a quotient. There's no remainder because it's a factor. Now, the original p of x is a cubic, so it stands to reason that this quotient has to be a quadratic. Not only that, it needs to start with x squared, so that when we expand the bracket, we get x cubed. It also needs to finish with negative 3 once again, so when we do this part of the expansion, we get the plus 6. We're not quite sure what goes in the middle, so I'm just going to write ax there. And let's just get this line out of the way. But I can find that a by looking at, let's say, the negative 3 here. Which parts of this expansion are going to give me x? That's going to give me x, and that's going to give me x. So, negative 3x, take away 2ax, has to be equal to this term, negative 3x. And straight away I can see there that that tells me a is 0. So what I have is that p of x is equal to x minus 2, x squared minus 3. Now I can factorize this as adopts. What it is x squared take away root 3 squared. So I have the x minus 2, and then the x squared minus 3 can be x take away root 3, x plus root 3.